Lesson 4D, normal distribution, which is our bell curve and our z-score. So here is our bell curve. Almost every piece of data that can be analyzed will form a typical type of bell curve. So height over time, height of students, okay, for ages. Then time to complete an assignment. Some people take very little time because they rush. Some take forever, okay? Same type of idea. Weight for infants. Okay, as they age, your weight will go up, and then it'll eventually go down again. So this is called our normal distribution. And yes, the word normal you must signify. Normal distribution always talks about the bell curve. Okay, so it's going to be forming a mountain, some sort of a mountain. Okay. Now, there are 6 main features of a bell curve. So, the 6 main features, and I'm just going to draw our little bell curve up here so we can see what's going on. So, it says the total area under the curve, if I were to shade everything under that curve, is equal to 1.0. And I'm taping without this. Let's plug her in and help us out here. That helps. Okay. So, if I shaded everything, that would equal 1.0, which is 100% of the data. It should be 100% of the data if I shade all of it. Now, it says the normal curve extends infinitely to the right and infinitely to the left. Because what we're doing is we're putting it on an XY axis. Here's our Y axis, here's our X axis. Okay? So, on our X axis, we're going to be going from -5 to +5. That's the one we're doing. Who's in the middle? 0, of course. Okay, 0's in the middle. So, it will never touch the x-axis, okay, because the x-axis is considered to be its horizontal asymptote. All of the word asymptote means is it's a line that you cannot touch. You can approach it, get real close, but you'll never touch it. Now, this one is a big word there, symmetrical about the mean. Now, the mean is always in the middle where the top peak is. So we'll put our mean, and in the calculator, it's x with a line over it. So that's our mean right down the middle. So on our bell curve, our mean is 0. And what it means is the data is symmetrical about the mean. So if you chopped it in half along 0 vertically, half of the data is on the right, half of the data is on the left, which means you've got 0.5 of the data here, 0.5 of the data there. Okay, that's shaded. So, 50%, that's what it's talking about here. So 50% of the data is left, 50% of the data is right. It has a mean of 0. That means your peak in the middle, okay, our mean is 0. The median and mode will also be identical in this case. Mean, median, and mode, they're all going to be identical the same. What we also need to understand is the standard deviation is 1, because I'm putting it on this number line from -5 to +5, and we're going to be having a standard deviation of 1. So we're going to be going up by 1s, 1, 2, all the way to 5, -1, -2, all the way to -5. Now, when we do have our big curve, it slides +1 and -1 almost to the edge of the curve. So they aren't evenly spaced to begin with. I'm going to show you what that looks like. So what it looks like is this. So if this is 0, our mean, they're going to put 1 way out there on the right. And they're going to put -1 way on the left. And then +2, +3, 4, and 5, they're very, very close in there. Okay, very, very close. The biggest spread is between here and here. It looks like they're not equal, but they actually are, okay? But it depends on, it's because of the bell curve and how much data is in each spot. And that's going to make more sense once we do a question or two. This is where it's talking about the mean, median, and mode are all approximately the same value, and they are right in the middle, okay? So your mean, median, and mode. And we always talk about the data. The data is under the curve, okay? All right, let's take a look at what it looks like for a picture. So this is how they divide it up. So the probabilities are in decimals. The probabilities are decimals. And this is how much information is in that space. So it's very, very little information as you get towards the outside. Now, this diagram shows the -1 and -2 and +1 and +2. It shows the spacing between them very equal. However, when you see it on a diagram that's on your calculator, it's going to push, like I said, +1 and -1 to the edges. And it's because of all of this information. If you look at that, that's 68% of your data is between -1 and +1. So 68% of the data is between -1 to +1, and that's one of our features. So let's take a look and answer our 8 questions here. So the first one, the mean of our data on this Z-score number line. This is called our Z-score number line. Z-score number line. And it's always with the normal distribution, which means bell curve. Okay, now you don't see -4 and -5. We use those for our outer boundaries, but you don't see them on this diagram. How come? Because there's very little information between them. So, the mean of our data, the mean is right in the middle there. So the mean is 0. The standard deviation basically means what are they counting by? What are they separated by? They're counting by ones. Okay, it's going up and down by ones. Please follow and fill in the blanks. How much percent of the data is above the mean? So what you're doing right now is you're looking at how much is above the mean, right here, all shaded in green. Well, that's half the data. So what percent is above the mean? 50%, half the data. Okay, next one. How much lies within 1? Now, whenever it says lies within 1 means from -1 to +1. That's what it's talking about if it says lies within. So we want from -1 to +1. We're just going to add up that percentages. So 34 and 34 is roughly 68% of the data lies within 1. Yes, 68.26. Now, how much lies within 2? Now we're expanding. Now we're going from here to here. How much data lies in there? If we were going to add it all up, because that's 13.6%, we're adding to 68. It's roughly going to give you 95%, roughly. Okay? It'll be a little bit more because of the rounding. And then within 3, we're going to expand it one more time within 3. And within 3, you're going to notice that 99.7% of the data. So almost all of your data lies within -3 to +3. That's why the hump is so big in -3 to +3. Okay? How much lies between 1 and 2? So now all we're doing is we're looking right here. I'm just going to uncolor it. Right there. So we're looking at this piece right there. How much percent lies in there? 13.6%. And how much is between 1 and 2 standard deviations below the mean? Will it be different? No, it'll be identical. It has to be identical because remember, it's symmetrical about the mean. If it's that much on this side, it has to be that much on the left side. Okay, and vice versa. All right, let's take a look at the next couple questions. We're going to do an example and see how it goes. All right, our first example is talking about a nurse. And this is where we use stats for most of us. The nurse records the number of hours that an infant sleeps during the day. She then records the data on a normal distribution curve. The values on the horizontal axis differ by 1 standard deviation. What is the mean of our data? So if I wanted the mean, where would I look? Right in the middle. Good. So let's find the middle number. What is our mean? 12. Perfect. Now, what is our standard deviation? That means what are they counting by? What are they going up by? They're going up by 2. Good. So our standard deviation is 2. Now let's figure out the values for A, B, C, and D. So let's work backwards. If we're counting by 2s, what's 2 less than 10? 8. And 2 less than 8? 6. Good. So A is 6, B is 8. We're going to add 2 as we keep going. Letter C, 16, D, 18. Good. 16 and 18. Now it says we want the percentage of days that the infant sleeps between 12 and 14 hours. So now we've got to see which section we're looking at. We're looking at this section right here. So how much was shaded on that section of our other diagram? You can look at the page before. How much is in this part? 34.13%. And how much between 8 and 16? Well, if I'm looking between 8 and 16, that is here. Now, that would be between -2 and +2 standard deviations. How do I know it's between -2 and +2? Take a look at how many steps below the mean we are. We're 1, 2 steps below the mean, so that would be -2. 1, 2 steps above the mean, that's +2. Look on your graph on a previous page. How much data is between -2 and +2? Roughly 95%. 95 point something, I think. 44. 95.44%. All right, now less than 6 hours. Well, if 6 is here, that means 6 would be a -3. We want everything left of -3 because it says less than. So how much data is left of -3 in a percentage? 0.13%. We look at our data. 0.13%. So 0.13% of those kids are going to sleep less than 6 hours. I think a lot of moms would disagree that are up in the night. All right. We're going to take a look at the standard deviation equation now. So now that we know how to use each piece of information, this is our Z-score formula. Now remember, why do we need Z-score formula? Because the Z-score tells us the number on the number line. Okay, so it tells us where it's located between -5 and +5. So, Z-score tells the location between -5 and +5. Okay, so it tells the location between -5 and +5. So the data, where is it located? That's what it's talking about. I'll give you a minute to write that down, and then we'll take a look at another example. What you see next are 3 different examples. So what's happening here is we've got 4 different variables. We've got Z for Z-score, X for the original piece of data, the raw data, mu for mean, and 0 with the loop, which is our standard deviation. Now, whenever we want to rearrange a formula, that's all I've done here is I've given you the rearranged formulas. You would expect to know this. You don't get all these formulas. You have to know how to rearrange formulas. So get used to using them. The easiest one to remember is the standard deviation one because it just switches places with the Z. So if you notice Z and standard deviation, they switch places. The top is not, just the bottom and the side. Okay? Over here, when they're sitting side by side, you must multiply first before you do the adding and subtracting. Okay? It doesn't show you brackets, but whenever there's two things sitting side by side, you got to multiply them first. Okay, for bed mass. All right, so those are the rearrangements from the formulas. And again, you will always be given the Z-score formula. You never have to memorize that one. But the other three, you'll have to be able to rearrange to figure out. Okay? All right.
It doesn't say above the box.
Sorry?
Like
Above the box, I just put number on the number line. So it tells us the location between -5 and +5 on the number line. Yeah. Okay. Good question. Okay. So the next diagram is just the diagram to show you within 1 standard deviation, 2 standard deviations, and 3 standard deviations. This is where you get most of your data. So they always tell us we need to know this one, and that one. Those are the ones you need to know the most. Okay? So whenever it says within one means from the -1 to the +1. Okay? They're not going to tell you, find out between -1 and +1. They're going to tell you within 1. You have to know what that wording means. Okay? All right. So that's the wording that I'm talking about. Okay? And again, the middle is 0, and here's our Z-score number line. Now, all this is talking about down here, here's our mean, and all this is, well, what is -1? What does it represent? Well, it's showing us that it's mean minus 1 standard deviation, however many steps that is. For example, when we had the infant sleeping, our mean was 12. Our -1 was 10. The standard deviation was 2. They were counting by 2s. Okay? So 1 standard deviation below. That's all it means. So we're representing our data. We're converting that raw score data into Z-score data. Here's our first example. So the heights in centimeters of 5 starting players of the basketball team are, and the mean height is 190, and the standard deviation is 15. So when you're reading the questions, try to always label what each number represents. Then it's easier to throw it into your equation. Letter A says calculate your Z-score to the nearest hundredth for the tallest player. So I want my tallest player, which is 212. So whenever we represent Z-score, we would say Z, and then we call it a little subscript. The subscript is going to be written in the bottom, right here like this. And that's where you're going to put what number you're figuring out. The Z-score of 212. All right. So we take our mean, our X data, 212, minus the mean, which is 190, divided by standard deviation of 15. Now, in order to do these equations, you always must solve the top first, then divide. You've got to do proper bed math, which means when you've got a fraction, you need to solve the top and bottom until they're 1 digit. So when we solve the top, we're going to get 22 over 15, which gives us 1.46 repeating. And we will locate that shortly. We're going to draw a diagram in letter C. B says calculate it for the shortest player. Our shortest player is 170. So we say Z-score of 170 equals 170 minus 190 all over 15, which is going to give us negative 20 over 15, which is negative 1.3 repeating. Now it wants us to locate it on our normal distribution. So we need to draw our diagram. Okay? Draw your diagram. Our mean is in the middle, and our mean is 0, which is 190. And we know our Z-score, our positive one is 1 at 1.46. So I'm going to make my number come down here, 1.46 repeating. And then I've got a negative 1.3 repeating. Negative 1.3 repeating. And now I'm going to shade everything in between it. That is where the data lies, between the shortest player and the tallest player on this team. Okay, so we found the Z-score for both of them, and then we drew the diagram so we knew where they were located. Okay, I'll give you a minute to draw that. This is an example of where the information is excellent in order to compare. If you were, for example, to compare your math, chemistry, and physics marks, just like Tammy here is. So Tammy's midterm marks are shown below, together with her class mean and standard deviation for each subject. So here's our mean, and here's our standard deviation. And here's our Z-score that we're going to calculate. Now, it says, determine which subject she performed best relative to the rest of the class. Well, we won't know that until we actually find out which Z-score she has. So, we need to figure out the Z-score for math, chem, and physics. So, here we go. Z-score for math equals 74 minus 68, all divided by 12. You're taking those two, subtracting them, and dividing by the standard deviation. That's what we're doing. That's going to give us 6 over 12, which is 0.5. So rounded 2 decimal places if there are 2 decimal places. We need to do the same thing for chemistry. Okay, so there's our Z-scores. We can fill them in that little spot in our table there. Z-scores for each. I'll give you a minute to write that down, and then we're going to figure out which one she did better at. Okay, as we can see when we compare, we're going to compare it to our bell curve. 0, 0.18, 0.43, and 0.5. 0.5 is furthest on the right. She did better in math. The next example talks about an average mark. They're giving you information but asking you to find the raw score. So I've already shown you which equation we need to use. If we're solving for x, that means we're solving for the raw score data, his actual mark. So whenever they're saying what was his real mark or what was his actual mark, they're talking about the original data. Okay, that's your x value. So we need to solve for x. That's the equation we need to use. Now we're going to label in the information the mean, the z-score, and the standard deviation. So it tells us average. Which one is that average? That's the mean. So average mean was 63. Standard deviation was 12. So I'm going to put a loopy by 12. Z-score was 1.5. Now be careful when you read the Z-score questions, because they may tell you above the mean or below the mean. This question said below the mean. What does that tell me about the number 1.5? It's negative, exactly. It didn't tell me that for this question, but be careful. Always pay attention to when it's talking about Z-score. All right, so in this question, we are going to fill in our numbers where they go. So our mean is 63 plus, now we take our Z-score, 1.5, and we're timesing by our standard deviation. That has to go first. So we're going to get 63 plus, the multiplying has to go first. That'll give us 18. So his real mark was how big? 81%. So his actual mark was 81%. Okay? So it's not too difficult. It's literally trying to label the information and match them to the equation and then literally do the bedmass to solve. Okay? So we're using skills that we already know how to do. It's just a matter of putting the numbers in the right spots. Number 6. The marks on the math exam at the university were found to have a mean of 52. Let's label mean. Standard deviation of 12. The professor thought the exam was too difficult and decided to adjust all the original marks by raising the mean to 65, so our new mean, and while reducing the standard deviation to 10 instead of 12. And he left the z-scores unchanged. What would the new mark for a student who received an original mark of 34? What would his mark be? Holy smokes. So this one is a multi-step question. So the first thing we have to do is find out the z-score for 34 on original data. Okay, so our original data was standard deviation of 12 and a mean of 52. So that's what we have to do first, is find out his his z-score for this. So, z-score for 34 is equal to 34 minus 52 divided by 12. That's going to give us negative 18 over 12, which is negative 1.5. Okay, so now we have a z-score of negative 1.5. That's where his z-score is. Now, the question says the z-scores are unchanged, but we want to find his new mark. Well, we're going to be using the equation we used in example 5, where we have to take our new mark is equal to our mean plus z-score times standard. So, our mean for our new information is 65 plus the original z-score that we found, which was negative 1.5. We got to times that by the new standard deviation of 10. Okay, so now we're using the new numbers. So the new information by our mean of 65, standard deviation of 10. That's where these numbers are coming from, our new numbers. And that's going to give us our new mark. So, what is dude's original new mark going to be? Well, he's going to have 65 plus negative 15. Well, that's just 50%. So, on the original exam, he got 34%. Because the teacher raised the numbers, he now gets a 50% on that exam. Okay? And things like that have happened. Okay? They do it a lot in university. They're very, very famous for it, actually. Yeah, pretty much. If they find that maybe it was an unfair exam, or maybe, I don't know, maybe the prof was sleeping one day and forgot to teach a lesson or two and put those on the test, who knows, right? All right, let's take a look at our last example here. Our last example is asking us to find standard deviation. So, I've written the equation we need to use for you. So our standard deviation is just a rearrangement of our z-score formula. We are now going to label within our diagram, or within our notes here. So it says a mean of 2.3. It says a weight of a particular cantaloupe is 1.7. So does that mean that's our X number or a Z-score number? 1.7, the weight of a cantaloupe. That's your raw score data. That's just X. This is X. This is your raw data. Now we talk about standard deviations, and this one's talking about standard deviations below the mean. So what does it mean about our Z-score? What does it mean about our Z-score if it's below the mean? It's negative. Good. So let's plug our numbers in. X is 1.7. We labeled our mean as 2.3. Our Z-score is a negative 1.01. It's negative because it's below the mean. We have to solve the top first. Negative 0.6 over negative 1.01. Negative dividing by negative will give us a positive. 0.5940 repeating to give us a standard deviation, always to 2 decimal places. 0.59. Okay? So there's our standard deviation. So every question is going to be asking either for a Z-score number, a raw score data number, a Z-score, a standard deviation, or a mean. You need to rearrange the equations and solve them accordingly. There's an example of every type for you, so that when you're doing your questions in your notes and your assignment, you know exactly what to do. Okay? This concludes lesson 4D.